For my project, I looked at the lateral mixing zone between the north and the west branches of the Susquehanna River at the Shady Nook site, which is located in Sunbury, Pennsylvania. So the north and the west branches of the Susquehanna River converge at a point slightly upstream from here, but they don't fully mix until another site slightly downstream from where we sampled, where a series of small islands helps to facilitate the mixing between the two. The darker blue here is the west branch, and the lighter blue is our north branch. So we were looking in this study to see where the zone was, where we went from the west branch to the north branch, and to see if and how that changed with different discharge and precipitation events. So to do that, we took a YSI multimeter and a GPS out with us on the river, and we tracked across from transect 1 to 2 here. From the data we obtained from the YSI, we determined that specific conductivity produced the clearest trends of lateral mixing between the two branches, so we used that to determine when we went from the west branch to the north branch. In moving between the two branches, the specific conductivity would jump anywhere from 20 to 40 points, and when that jump started to occur, I would place a point on our GPS, which is where all of these arrows correspond to. Each arrow corresponds to a different day that we found the mixing zone out on the river. And after that, I would go back and look at the discharge from the north branch to the west branch, and this area in here, just to get an idea of what was going on at different points on the river before we were taking these points and right when we were taking these points. So from doing that, we were able to determine that the discharge does have a significant effect on where we find this lateral mixing zone. So we found from here, this point, that the west branch will push up until a certain point on the north branch, but the north branch will start to push back on the west branch at a certain point because it is still flowing. So at this point here, there had been a small rain event up on the area, but it mostly affected the west branch, as when rain comes through this area, it'll hit the west side before it'll hit the north side of the river. So that's why we have this mixing zone all the way over here. The north didn't have as much precipitation affecting the discharge as the west side did. But then we also have events like this one here and these two here, where it rained steadily for a period of at least 3 to 4 days. And that allowed the mixing zone to kind of even out in a way because the north and the west branch were equally pushing back on each other. And that's where we kind of get into the goal of our study here. In a long-term effect, we want to get 2 permanent monitoring stations in here so that we can continuously monitor what's going on down in this area to really see how often this shift occurs during the day and over a long period of time, including through the seasons. While we were out, we also took water samples from sites 1, 2, 3, and 4. We only have data from sites 1 and 2 up on this poster, as we found that after looking through all of it, that sites 3 and 4 were essentially the same as site 2, so it was a little bit redundant having it all up here. But this plot here corresponds with site 1, this plot down here corresponds with site 2. So we took our samples and we have the YSI data, we also have a chemical oxygen demand, and we ran these samples through an ion chromatography system, so we do have some water chemistry up here as well. But this will show you that the specific conductivity is the biggest indicator when you're moving from one body of water to another. It's the biggest difference between the two, although the nitrates and the nitrites are slightly different, as well as the dissolved oxygen content of each side. So the water chemistry was mainly done to really show that we are dealing with 2 separate bodies of water here. And because we had all of this data, we decided to calculate a WQI, or a water quality index, because we had the data. So that's shown here. We had 5 days where we had all of the 11 parameters needed to calculate this WQI, and we found that for site 1, our WQI was between 63 and 74, and for site 2, it was between 65 and about 72.5. Both of these numbers indicate that the water quality in the Susquehanna River at this point is fair, which is to be expected for this river. Now, a WQI of fair just means that the water may not always be suitable for drinking conditions, but it's still able to be used for recreational conditions. So from all of this, we were able to determine a lot of different things, and we want to, in the long term, it would be interesting to do this study again in a summer when it isn't as rainy as it typically is. This last summer was a lot rainier than normal, but that would be a good direction for this study to go in the future.